In this video, we're going to talk about the application of Newton's second law of motion involving two blocks of different masses that are connected by a light string. This is Physics is Easy with Mr. Jesse. Two blocks of masses m and m with the capital M greater than the small m are connected by a light string. The string passes over a frictionless pulley of negligible mass so that the blocks hang vertically. The blocks are then released from rest. What is the acceleration of the mass capital M? So if we are going to draw this situation, so we have two objects. They are in a pulley connected by a light string. One of the object is capital M while the other one has a smaller mass. So obviously, by just looking at this, we could clearly see, or we could clearly infer that this mass, or that the bigger mass will go down, while the smaller mass has to go up. In dealing with problems like this, the first thing that we need to do is to draw the free body diagram of the masses that are part of the system. So let's draw the free body diagram of the bigger mass. So we have here the force of gravity, so we call that W capital M, and we also have tension that is directed upward. On the other hand, for the smaller mass, the forces would be the weight of the smaller mass, so we are going to call it W small m, and there's also tension, and that's directed upward. Tension would always be along the string and opposite to the direction of the weight. It is also very important to remember that the tension that exists in both objects would actually be equal. So the tension right here is equal to the tension that is being exerted on the smaller mass, so they're equal to each other. And now let us write Newton's second law of motion for both masses. So we'll say the F net that is acting on the bigger mass would be equal to the mass capital M multiplied by its acceleration. And let's expand that. F net is just the sum of the forces acting on the object, so we will have tension directed upward, so positive, minus the weight of the bigger mass, and that is equal to M times the acceleration. But you have to take note of the direction of the acceleration, so that would be negative A, because the capital or the bigger mass M is directed downward. Again, it is very essential that as you expand the F net is equal to MA, you have to ask yourself, where is the object going? Because the acceleration or the sign of the acceleration is very essential in setting up this equation that we have here. Okay, so expanding this further, we are going to have tension is equal to the weight of an object is just equal to the mass of the object multiplied by the acceleration due to gravity. So therefore, the weight of the bigger mass would just be equal to capital M multiplied by G, and that is equal to negative M A. So this is the equation for the bigger mass if we are going to apply Newton's second law of motion. And now we're going to look into the equation for the smaller mass in relation to Newton's second law of motion. So again, we always start with F net is equal to MA, and this time we are now solving for the F net of the smaller mass M. So expanding this, we will have F net. We look into the forces acting on the smaller mass. We have tension going up, so that's going to be positive, minus the weight of the smaller mass is equal to mass. And again, you have to take note of the direction of the object's motion. So since it's directed upward, so the acceleration for the smaller mass is going to be positive. So now let us expand the weight of the smaller mass. So that's going to be tension minus the weight of the smaller mass is just equal to its mass multiplied by acceleration due to gravity, and that is equal to MA. So now we have our second equation. Now let us go back to the problem. It is asking us what is the acceleration of the block of mass capital letter M. So basically we need to solve for the acceleration. So what we could do here is to express any of this equation. It could be this equation 1 or equation 2 in terms of tension, and then use substitution to solve that problem. So what do I mean by that? For example, let's look at equation number 1. Let's look at equation number 1, and let's change that in terms of t. So for instance, that's gonna be equal to t. I will be transposing that term to the other side, so I'm gonna have mg becomes positive minus ma. Again, I'm just transposing this term to the other side, and by doing so it will become positive. The next thing that I'm gonna do is to substitute this t here, which is equal to mg minus a, into the t that we have on the second equation. So the second equation is equal to, or the second equation we have t minus mg is equal to ma. Again, this t right here is equal to this term. So I'm going to substitute this here, so that I will now have, instead of writing t, I will now have mg, capital mg, minus capital ma, that's my t, minus small mg is equal to ma. And now I just have to manipulate this equation in such a manner that I will get the acceleration on one side of the equation and the rest of the variables on the other side. So what will I do here? I will transpose this term to the other side where a is. So to do that, I'm just gonna have capital mg. Wait, let me just be consistent with the color. I will have capital mg. Again, this term goes to the other side, so what's left would just be this minus mg is equal to capital ma. Again, I am transposing this term to the right side of the equation, plus small ma. Alright, and since I am interested in a, I am going to factor the right side of the equation, so that I'm going to have mg minus small mg is equal to capital letter M plus small letter m, close in parenthesis a. Alright, so we will now have we could now divide both sides by the term capital M plus small m divided by capital M plus small m, so that I will have mg minus small mg over capital M plus small m is equal to a. And now moving forward, we could further factor out the g on the numerator of the left side of the equation. So I'm talking about here, there's g on the first term, there's also g in the second term, so I could factor that out, so that I will have m minus small m multiplied by g divided by m plus m, and that is equal to a. So now we have solved our problem, which is actually choice E in this particular question. And that concludes this tutorial. Always remember, physics is easy with Mr. Jesse.